of size 10. And again, if you want, so now when getting to the component, so we've got 10 of these things, so we would access the nmax component of the first element of this array by subscripting the array and then the component selector, like so. And you can, this goes forward, you can use these things as dummy arguments to procedures, and you declare them in the same way, and so forth. Okay, so another thing I'm going to recommend very strongly here is that one puts type definitions in the specification part of a module, and indeed some derived type features actually mandate that this is the case. So if you put your type definitions in a module, and you can make them available to other program entities that use the module. Okay, so from other languages, one concept that may be familiar is the having scope for your components. So the formal situation is the following. So there's an optional private statement here by which you can declare that the components are actually private, so they can't be accessed from outside the from the outside world. So the default situation is formally this one, where the type is public and the components are public. So if you want to have an opaque type in which the components are not public, you can declare it like so. So you can use the type name, you can pass around entities of this type, but you can't access the components in the outside world. Okay, hopefully that's fairly clear. So stick your type declarations in a module. You can always use the components within the module, but if you want the type to be an opaque type in which you don't have access to the components outside, make it private. You can do some fairly simple operations in terms of bringing data into existence with initializations, so-called type constructors. There's an example here. So if you want to have we have a definition with 3 components like so. We declare a variable of this type A. One can initialize it with a constructor in a reasonably concise fashion, like so. That's quite can be useful, but there are certain restrictions in that you must agree on the order between the constructor and the definition up here. So the integer part is first, then the real part, and the complex part is third. If you have something that is an allocatable array, for example, or a pointer, the corresponding initialization in the constructor should be this special value null, which I perhaps will come on to in the next talk. Okay, so if you want to have a default initialization for objects of a given type, you can provide in your definition some default initial values by specifying some initial value. This is true for values, but the exception is you don't specify an initial value for anything that's a pointer or an allocatable. Entity, the default initialization would therefore look like that. You just give an empty constructor, and then these values would take on the values you've given up there, and anything that's like an allocatable array will be not allocated. Okay, so that's the basis of forming your own data structures. This mechanism is extremely powerful ultimately in doing any real programming problems, and so should strongly consider making use of them. As a small example to have a go with here, I've provided in these two files an implementation of a very simple pseudo-random number generator using a type. So have a look at that, see how it works, and there are a couple of questions to be answered down there at the bottom. I'll give a few minutes for you to have a look at that.